Well, welcome back. Tonight's topic is on shifting functions. So another word for shifting would be translating. And you probably talked a lot about shifting or translating back in geometry. Basically what we're describing is we're taking a function and we're not changing its size or shape. We're basically just picking up and maybe moving it to the right and moving it down. So now it looks something like this. Again, the size and shape aren't changing. We're just shifting or translating functions. So our goal is to focus on two types of shifts or translations tonight. That would be a vertical and a horizontal shift. So go ahead and title that in your notebook. And then we'll carefully write this sentence out. Vertical shifting. The function f of x plus k shifts the graph up and down. If k is positive, the function shifts upward. If k is negative, the function shifts downward. Now here's where I make a little note to myself. Do you notice this k is outside the parentheses? Okay, so perhaps you should make the same note to yourself. The k value, or the vertical shift, is sitting outside of the parentheses here. Now you're probably guessing I'm saying that for a reason. Guess where the horizontal shift is sitting? The function f of x plus h shifts the function left if h is greater than 0 and right if h is less than 0. Okay, so now again, notice where the h is sitting this time. H is sitting inside the parentheses. Therefore, that's a horizontal shift. The other big thing about h, you'll notice, is that it goes left if h is positive, and it goes right if h is negative. So basically, it does the opposite of what the sign is. Okay, so again, I would put these notes in your notebook as well, opposite of what the sign is. So now we'll take a look at a few quick examples. Number 1. F of x plus 3 minus 4 shifts where? Okay, well notice inside is telling me this is a horizontal shift, and I'm going to go the opposite we just said. So this is going to shift my graph left 3. This minus 4 is outside, so this is going to be the vertical shift, and it's literally going to shift it whatever it says, so down 4. So I need to know, as soon as I see this function, I'm going left 3 and down 4, no matter what the shape is. Number 2, describe the shift. So we'll do one more together. Inside, again, is my horizontal shift. And because it's negative, I'm actually going to go right 4. And the outside is my vertical shift, so I'm going to go up 3. All right, I've got 2 for you. Questions 3 and 4. Jot them down and write down their shifts. Well, notice I just have an inside, so I'm just going to go a horizontal shift, and I'm going to go right 5. Notice there is no vertical. Nobody's being added or subtracted. And in number 5, I'm going to do the opposite. I have a vertical shift this time, no horizontal. So I'm just going to go up 5. So basically, you've talked about common graphs back in Algebra 1, and what we need you to be familiar with without using your graphing calculator are the common graph y equals x squared and the common graph y equals the absolute value of x. Now, thus far, we've talked quite a bit about x squared, and I'm assuming you know what absolute value of x looks like from your algebra days. But either way, we'll get them sketched in our notebook, and we'll talk about the shifts. Okay, so I know that x squared is a parabola. There's no shift, so it's centered at the origin, and it's positive a value, so it opens upward. Okay, we call this the parent graph of x squared. Absolute value. Now, in case you forget, it takes 2 seconds to make a table of values and plot points. Okay, so if you don't know what it looks like, you don't need your calculator, you're just going to plot points. If I plug in a 0, the absolute value of 0 is 0. If I plug in a 1, I get a 1. A 2, a 2. A 3, a 3. Well, that's pretty easy. 1 looks like that. Now let's make sure we plug in some negatives. If I plug in a -1, the absolute value makes it positive. If I plug in a -2, I get out a +2. A -3, a +3. Absolute value makes a V. Okay, and most people remember that by the word value. Absolute value makes a V. So these are two common graphs we're going to ask you to sketch without your calculator, and then we're going to ask you to shift them without your calculator. So example 1, y equals x minus 3 squared plus 1. Okay, you should easily be able to sketch this graph without a calculator. I'm saying this tells me here I need a parabola. This tells me I need to shift horizontally right 3. I'm going to do the opposite. And this tells me I'm going to do a vertical shift up 1. Okay, so I'm going to move from the origin because the x squared is telling me to use this parent graph of the parabola. Okay, so you can sketch that if you want. That's what it normally looks like. And I'm going to take it and I'm going to go right 3, 1, 2, 3, up 1, and draw my new parabola. Okay, so notice nothing should have changed size or shape. We're just shifting. Example 2. Y equals the absolute value of x minus 3. Okay, so let's get our parent graph down. Absolute value of x. The second I see that, I'm making a V in my head. And now I'm saying, where am I going to shift this V? Okay, well, there's no number inside the parentheses, so there is no horizontal shift. The 3 is outside, so I'm going to vertical shift down 3. And I'm going to sketch that. I'm not changing the size or the shape. I'm just taking this graph and translating it down 3. Okay, so again, two graphs we need to be familiar with without the calculator is the x squared graph and the absolute value of x graph. The function f of x is graphed to the right, so I'm just going to go ahead and label it f of x. A second function, g of x, is defined. Okay, so when they're talking about f, I'm going to use this graph. When they're talking about g, I'm going to use this equation. What is g of 0? So I'm going to go and replace all my x's with 0. So g of 0 is equal to f of 0 minus 2 plus 1. Now I can clean that up a little bit. G of 0 is equal to f of, well, 0 minus 2 is -2 plus 1. Okay, so now I'm just going to do order of operations. I'm going to find f of -2. Well, anytime I say f, I'm going to use the graph. F of -2, so I'm going to substitute -2 in, and my output happens to be -2. Plus 1 is equal to -1. So let me say that for you one more time. I'm going to go to -2 on the x-axis. The output also happens to be -2. And then I'm going to say plus 1 to get my -1. What is g of -2? Well, substitute it in. So let's see, if I clean that up, I'm going to get f of -4 plus 1. And anytime I say f, I have to use the f function. So I'm going to go out to -4, and I'm going to see that it has a height of +4. So I'm going to say I get 4 plus 1, which is 5. Part C. Sketch the graph of g on the grid by identifying the shifts. All right, well, we had f of x minus 2 plus 1. So where's this graph shifting? Well, hopefully we're feeling pretty confident. This is telling me I'm going to have a horizontal shift, and I'm actually going to go right 2. I'm going to do the opposite. This is telling me a vertical shift, and I'm going to go up 1. Now, you don't just randomly pick a few points. You're going to take all the points and do that. So I'm going right 2 and up 1. So as I go back to graph this, I'm going to take the solid points that I can see. I'm going to start with this point. I'm going to say, okay, go right 2 and up 1. I'm going to plot that one. Now I'm going to plot the next one that hits one of the corners there. So I'm going to go right 2 and up 1. That's going to put me there. I'm going to take this corner here and go right 2 and up 1. It'll put me there. The next nice one I see that hits the 4 corners there, I'm going to go right 2 and up 1. And then I'm going to do that last one, right 2 and up 1. And then I'm just going to connect them. And remember, you should be getting the exact same function, just shifted. Okay, it shouldn't change size, it shouldn't change shape, we're just shifting it. Right 2 and up 1. All right, next example. Given the quadratic function f of x minus 3 squared minus 4, describe the shift that has happened to produce f of x. All right, pause it. Write down the 2 shifts you see happening. Well, I'm hoping your answer agreed with mine. I went right 3, and I went down 4. Now again, I just want to make a note that this is still a parabola. And how do I know that? Is that it has this quantity squared. That's what gives it away. What is the new vertex now? Okay, well, I went right 3 and down 4. Remember, the parent graph is centered at the origin. I just picked this graph up and I shifted it right 3 and down 4. So my new vertex is 3 comma negative 4. I might have jumped the gun here. Sketch f of x, and over what interval is f of x increasing? So I'm going to make a nicer sketch. So remember, when we talk about increasing or decreasing, you can basically think I have to read from left to right. So I'm going in this direction. And what's the slope of it? Or if you were skiing, would you be walking up or down? So when I start on the left-hand side, I'm clearly going down, so that's decreasing, till I get to my low point, and now I'm going up. So I just want to be clear, this is the section that's increasing. Okay, so I would say I'm increasing from the x value of 3 forever. So from 3 to infinity. And we're going to wrap parentheses around that. Now you might be saying, well, how come you didn't put a bracket at 3? Well, at 3 I'm at my lowest point. I'm not actually increasing. I'm just at the bottom. I don't increase till I move past 3. So from 3 to infinity. Okay. Now it says, let's make a more detailed sketch and find the zeros of this function. Alright, so to get more details, I'm just going to plug more points in. I already know the point 3, negative 4. So I have that point for sure. Okay, so I'm just going to plug a few more points in. I'm going to make a table of values, basically. What if x is 0? What do I get for my y value? Well, 0 minus 3 is negative 3 squared. That's 9. 9 minus 4 is 5. So I've got 0, 5. If x is 1, 1 minus 3 is negative 2, squared is 4, 4 minus 4 is 0, so 1, 0. If I plug in a 2, 2 minus 3 is negative 1, negative 1 squared is 1, 1 minus 4, negative 3. So 2, negative 3. I'm going to plug another point in. Let's plug in 4. I'm sorry, how about 3? Well, we know 3. How about 4? 4 minus 3 is 1. 1 squared is 1. 1 minus 4 is negative 3. If I plug in a 5, 5 minus 3 is 2. 2 squared is 4. 4 minus 4 is 0. And I'm sure you can anticipate the next height should be 6 or 5. So now when I graph that, I've got a more detailed sketch. And again, I just plug numbers into that table. Part E, for what values of x is f of x greater than 0? Okay, so now I'm basically saying, when are the y values greater than 0? So if I look at this picture, my y values are greater than 0 anytime I'm above the x-axis. So I'm just going to box it in. I need to describe this section. Okay, now you'll notice if you ignore the bottom half here, there are 2 pieces. There's this piece where it's above, then there's a break, then there's this piece. So I need to express this 2 ways. So I'm going to say I'm always going to be above from negative infinity until my first 0, which is at 1, and from 5 to positive infinity. So again, I'm describing this section, left to right, negative infinity to 1, then this section left to right, 5 to infinity. Alright, so here's another typical multiple choice question that we've seen. A function f of x has a given domain from negative 3 to 10 and a range y is less than 22. What are the domain and the range of the function f of x minus 4 plus 5? Now, I have no idea what this original function f of x looks like, but what I do know is on the x-axis, it basically goes from negative 3 to positive 10, And on the y-axis, it goes up to 22 and below. Okay, so basically, I just need to know where I'm going to shift this graph. So it starts someplace at -3, it has a height of 22, and someplace it has an x value of 10 here. So if I were to pick this graph up and shift it, where am I shifting? Let's start horizontally. I'm going to shift this right 4, which means I'm going to take all my points and move them to the right 4. So if -3 was my smallest x value, what is my new smallest x value going to become? You've got it. We're going to add 4, and I'm going to say my smallest x value is going to be 1, because I'm taking this point at -3 and I'm shifting it right 4. If my largest x value is 10 and I have to shift right 4, my highest x value now will be 14. So there is my new domain. Okay, I just picked up all my x values and moved them to the right 4. Now, my y values, okay, I'm going to shift them all up 5. So if currently my highest value is 22 and I shift everybody up 5, I'm going to say now my range are y less than or equal to 27. Let's try another one. A function has a given domain 2 to 5. And a range -3 to 6. What are the new domain and range of this function? Well, again, domain is my x values, and that's my horizontal shift. Where am I shifting everybody? I'm going to go left 2. So if I was currently at 2 and I go left 2, kind of just picture you're currently at 2, I want you to go left 2, I'm now going to be at 0. And if I'm currently at 5 and I go left 2, I'm now going to be at 3. So my new domain should be 0 to 3. My range was -3 to 6. And now I'm taking all my points and I'm shifting them down 6. So if my smallest y value is at a -3 and I have to move it down 6, I'm now going to have a y value of -9. And if my largest y value was at 6 and I move it down 6, my highest y value is going to be at 0. Alright, we're doing well here. The graph of f is shown below. The function g of x is defined by g of x equals f of x minus 4. So let's just go ahead and label this f of x so we're clear, and we've got g of x here. So what are the zeros of f? Well, that means focus on this function over here. Zeros are just where my graph crosses the x-axis. So hopefully you nailed 2 of them. I would say x equals 0 and x equals -3. Show that x equals 4 and x equals 1 are zeros of g. Well, that just means when I plug in 4 and I plug in 1, I better get the answer of 0. So g of 4 is equal to f of 4 minus 4, which is really f of 0. Now I see an f, so I have to go back and use this f graph. F of 0, if I go to 0, I should get a height of 0. So check, I showed that that's a 0. We'll do the same thing of g of 1. G of 1 is equal to f of 1 minus 4, which of course is -3. So now I need to find f of -3. F of -3, you can see right there, is a 0. So check, we've showed that those are zeros of g. Evaluate g of 0 and g of 4. Okay, well, g of 0, I'm just going to plug 0 in that function, so I'm going to get 0 minus 4, which is f of -4. So I'll have to go evaluate f of -4. So I'm going to count over 1, 2, 3, 4, and it has a height of -3. And g of 4, which is equal to f of 4 minus 4, which is f of 0. So if I go back and look at f of 0, f of 0 is 0. And lastly, it's a sketch g of x. So we've got enough points plotted here. We know g of 0 is -3, g of 4 is 0. Or you can take the fact that you know you just have to take this graph and you have to shift it right 4. So that's what I'm going to do. I'm going to take all my points and shift them right 4. So I'm going to start at this bottom point and go over 4. 1, 2, 3, 4. Then I'm going to pick the next nice point, which looks like this one, and go over 4. And the next nice point looks like that one, and go over 4. And here's my next nice one. 1, 2, 3, 4. And maybe that one. 1, 2, 3, 4. And I can easily go get that function. Whoops, and this one. 1, 2, 3, 4. So again, it should look like the same size, just shifted or translated. Well, hopefully you're feeling confident in our horizontal and vertical shifts, and we'll get some great practice in tomorrow. If you have any questions, you know where to find us.